Hello,
Hi,
how are you?
doing okay.
Can you share your screen to see how much you have done?
Hold up.
Can you look at browse the syllabus? Let me see where you are. So
I
you
think
are
the
you
modules.
are, you are in the Unit 3.
Yeah, I'm in Unit 3 right now.
Okay, you have to be a little bit faster, okay?
Yeah, I'm almost Unit 4.
Actually, it's lesson 3, uh, chapter 3, I should say. Unit 1, that chapter 3. Okay, you have to be faster, okay?
Okay.
Because the unit one is pretty easy. You have to go faster. Otherwise, later you will bump into problem when the things get harder. Okay.
Okay.
Did you have a schedule?
It's right here.
You have to go faster than what they have. Okay.
Mm-hmm.
Their schedule, because you need to save some time for the second semester, and you should start second semester early.
Mm-hmm.
Otherwise, your AP exam is actually will finish way before before the exam. Otherwise, you cannot have time to prepare for it.
Okay.
Okay, okay. Anyway, I roughly know where you are. Keep working hard, okay? Keep working hard now. So last time we talk about talking about data type. Now you are on these operators. So why am I talking about your schedule? Because if based on the chapter I have, we have 21 chapter. At this moment, we still on a one chapter per week pace. That actually too slow. Okay, that means you will have to finish the whole course right here. We have 20. These are my chapters.
Mm-hmm.
So you are just up to the chapter 3. That means you still have a lot of things you need to pick up.
Okay.
And that would take a long time. That would take a long time, probably 1 year to finish. If you keep doing like this, you have to use 21 weeks. And lower part will take more time usually. Okay. And this one, we just work on the APCSA. We still have another one, APCSB, you need to work on.
Mm-hmm.
Otherwise, you cannot compete. So you have to be a little bit faster, okay?
Okay.
Okay, anyway, let's go through I'll try today to go over probably today's goal. Let's go over probably B2 and B3 and B4 at least. Okay,
Okay.
at least minimum, like what we need to finish. Okay, operators. So operators. So you have any questions so far?
No.
So operators are mathematical operators. So this one I think is easy. First thing you need to know is package, class, method, statement, expression, and token. These different terms you need to remember. Okay. So what is token?
I don't know.
So variable hour is a token. 3 is a token. 3.4 is a token.
Wait, so just any like variable?
No, not only that. A curly brace is a token. Right side curly brace is a token.
What?
Okay. Curly brace is a token. Bracket is a token. right side bracket is a token, semicolon is a token, hour is a token. Everything is a token. Let's actually talk about token. So token is, let's actually pick English as an example. So let's talk about token. So if I say I like, let me use typing. Okay, it's actually when I write, it's not really that great. So if I say I like you, how many tokens are here?
1, 2, 3, 4, 5, 6.
Hmm?
9.
No, there are only 4 tokens.
What?
So I is a token, like is a token, U is a token, period is a token.
Is this space not a token?
Space is not a token, no. So what it means by a token is it actually is a, let's see. Token is a token. Token is a symbol. Token is a coin. You go to like say Disneyland or some of the arcade, right? You play a video game, right? There are some arcade that you go to there and then you change your dollar to some tokens. So token is some symbol or something that you can carry that actually used for certain meaning. So right here, a token is a word. A token is a symbol. A token is carries some grammatical unit. So period by itself has some meaning. That means that your sentence is finished. You is a token. It means a person. Like is a verb. So each one of them is a word or a symbol or it forms some grammatical unit. We call it a token.
Okay.
Does that make sense?
Yeah.
Okay. So let's see. Let's actually use a Java as an example, like integer a equals 3 semicolon. So right here, how many tokens?
Is integer considered a token?
I'm asking you, you tell me how many tokens here it is.
5?
So int 1 token, a 1 token, equal 1 token, 3 1 token, semicolon 1 token. So this is 5 token, okay? So token is the number of the grammatical units that you have. So when you do AI the same thing. AI talking about a lot of tokens. So you actually want to translate the English tokens to say, let's assume that you change it to Chinese tokens. So that you may need AI. Is okay?
Mm-hmm.
So that actually why AI has a lot of token and parameters. That's because you do have a lot of tokens. So right here, token means symbols, means grammatical units. So basically, let's go back. So the tokens means like a single variable is a token, a plus sign is a token, a equals is a token, semicolon is a token. So the basic grammatical units in your sentence is called a token. The next one is expression. Expression is hour times 60. So some expression give you some value. So here, this one give you some value. Some value may be 120 if hour equals 2. So expression will give you some value. Okay. And then next one is a statement. The statement is you have our one token, equal one token, integer list one token, curly brace, parenthesis, two token, this one token. So this one is a whole sentence. A whole sentence, we call it a statement. And a function is like a paragraph. You have a function that puts many statements in there. And then a class is actually a assay. The assay that you're working on a certain class, say circle class, that actually is an assay. Then you have a package. Package means that like a book, there are several chapters. Okay. So this one show you how the organization of a Java program starting from token up to package.
Wait, so method is just a function? Method is just a function?
Method is a function. Method is a function as the name in object-oriented programming. It is a function. It is the name of the function in object-oriented programming.
Okay.
Okay, so it's a special way of calling function. And then package, usually you are all lowercase. Class, you have leading uppercase. So this one we call it upper camel case. So every letter you put it capital, it's actually for a class. Then method is lower camel case. So first words, first letter is lowercase. Second words, first letter is uppercase. This one we call it lower camel. Camel C is uppercase. Case C is uppercase. It's called lower camel case. Is that okay so far?
Yeah.
So these are just basic programming units. Okay, this is okay. And then you have expression. Expression will give you some value that you know. Okay, and statement. Statement is one sentence. Okay, this one. Control flow. So you have a program. Program is like an article or a essay. So every program, minimum program unit that can be compiled is a class. So you always write a class. And each class will have somewhere you start your program. So that where you start your program is called public static void main. Okay? Okay, anyway, these are the program. Okay, so too much, we skip. Next one is static program. Static program is you have a program that has static over there. So this static is not object-oriented, it's a regular program. So usually before we teach object-oriented programming, we teach you static programs. So static just means that you will have function, calling function, call another function, then that actually is the static program. And later we'll talk about static and non-static. What is the difference? I'm not right now. Okay. So
Wait,
this one,
it calls two different things.
they are different things, yes. When you have static or no static, it's different.
So you just wait, I'm just trying to understand because I'm a little confused about like what static means.
Static right now, it just means that you can have, you start it from here, you call another static function.
Oh, okay.
Right here we have class called physics. So this is a program unit that related to physics. So you have light speed. You have E equals mc squared. Okay, whatever. So this one is a physics calculation. Perform a class. This one is actually static program, so it's function calling function. Another kind of the program is object-oriented program. So this also is a class. So they write it in different way. Okay, they write it in different ways. So let me show you a little bit of this different way of writing program. So let's use this circle, calculation of circle area to demonstrate the difference between the static program and non-static program.
Okay.
Because it's slow, reacting slowly. It's also slow. I don't know why.
Hmm?
My computer is slow.
Oh,
I'm waiting for it. Maybe the hard disk is too slow. Still waiting for it. Okay, so let's actually have something called circle. Circle one. Okay, let's call it circle one. So this is circle one is static program. So if we want to calculate the area for a circle, we do start with a public static void main. That's actually the regular program that we will write. So let's have the public static void main. Okay, so you want to get some input, so you need to import java.util scan.
does UTIL mean utility?
UTIL means utility, yes.
Oh, okay.
So you have a scanner input equals new scanner system.in. So last time I teach you what is system.in.
It takes the input from like your keyboard.
Yes. So you do take the keyboard input from keyboard, but before you do that, you have to say system.out. Okay, so what is the system.out?
It goes in the computer and shows it to you on your screen.
Okay, good. At least you need to, at least you remember what is system.in, what is system.out. Okay, that's good. So you do double, okay, radius equals input that next double. So next double will read in one double token, okay? After that, you will calculate the area equals mass.pi times. Mass.pi is the pi number constant, okay? Times radius.
Is there a
System.out of the F the area of a circle with percentage 0.2F is percentage 0.2F backslash N. Here you have radius and area. Yeah, your question?
Is there a way to like get is there a squared function? Like
Square
can you
function, yeah, there's a square function. If you want to use this one square, you can use match the power of the radius.
Oh, okay. I see.
There is no such thing. There is no such thing as a radius. Start to know this one in Python. There's no nothing there. Okay.
Mm-hmm.
Python yes, but not in Java.
Okay.
So right here you do have you want to print it. So this one is actually called formatted print. Formatted print. This one will be used to replace this variable. This so percentage sign is something you want to replace. So
Mm-hmm.
0.2f means that after the decimal point, I want to print two digits.
Oh.
So you may have more digits, but I will actually cut to only two digits. So 0.2 means after decimal point, two digits. F means floating point numbers. Okay,
Mm-hmm.
so this
Wait,
one
so
will.
so the F inside of the quote has nothing to do with the format?
This one, it is not because it's actually because you are using formatted print. So this one is related to the format. Yeah.
Oh, okay. Okay.
Then you compile and run. Okay, this is a regular program we write. So you do have a class, and this class is a program class. So this kind of a class, we call it a program class. So you only program, so it's a static calling static class.
Oh.
We call it static program. So here you do have a static. Now let's look at another one. Another type of data, we call it object oriented. So let's use a circle. So this is a circle class. I spell it wrong, but it's okay. Let me change it. So this one is a circle class. So this is circle class. We do create some data that's called double radius. So this one, no static. So no static, we call it instance variable. So you have a circle and then double r and then radius equals I. This kind of the class we call it data class. So data class create a data type. So this data type is called circle. So this circle we do have a radius called r. Okay, after that, let's actually have with string, full string. This one will convert the object to a string. So you will do return, okay, and then by bracket, okay, that's those circle percentage point to equals percentage point to and here let's use string format on radius and then here area. So here we need to have a function called public get area.
Wait, I don't understand.
And later, okay, later, let me finish the typing. Okay, so this one we do have create a class. This class, nothing is static, totally no static. Totally no state. This kind of program, we call it a data class. Compared to another one, let's actually put it over here, okay? The other one, everything is have a static. So this static one is very simple. You can understand it that you actually do read in data and then calculate it and print. Okay, so this one we know. This one is the regular program that we know. Now let's look at this circle. This one, there is no main function, no public static void main. So this one, can you start this program from here? No, you cannot. You cannot run this program right now. It's only purely for data. So this type of program, you cannot run it, compile, it can compile, and there's no main function you cannot run. You cannot even run. You actually look at it, you cannot even run. So in this case, you need to write another one called long circle. So this long circle is another program that you want to run. So this one, you do need to have public static void to electric ARTS. You do need to do import Java UTI and the schema. Okay, so you do want to do that. Then right here, let's copy this whole thing over. Put it over here. So right here, we still want to read the radius, yeah. And you read in the radius, yeah. This one, we don't want to do that. This one I will actually delete that. So far we read in data and then read in the radius. So far that's it. But the next one, this is circle in this one, you actually calculate area right away using the static program. This one, we want to use this data class. So we will say circle C1 equals new circle 3 radius. So this one will create a circle object. So this circle class is a class. This class is purely for data. What kind of data it is? It's actually the circle kind of data. So we do have a class called circle, and we can create a circle called C1. This is C1 will have a radius by the keyboard input. So we actually create a radius and then create an object called C1. Then we do we want to print. So we actually will do this. Let me copy this one over. So this one will copy. That's actually we'll copy this over. So after you create a C1, the area we will calculate will be C1 get area. So this is C1 get area would be, this is circle 1, calculate its area. And you calculate this area based on what? Based on the get area function defined right here.
Oh.
So this type of function, we call it a method. So method is object-oriented method. This one we also call it instance method and no static. So what I want to say is when your function there is no static means you have a class, then you create a circle C1, then this C1 has a method called get area. then you can run that function. This is called instance method. It's a method belonging to the object. Only C1 calculate, you will use this get area function. So that's different from the main function right here. This one actually, whoever runs this main function will calculate this. This one is different. This one only the C1 can get that area.
Yeah.
Okay, even though the result is the same, we print out the same way. But we are using this static function to run that non-static function. So right now we are using this run circle to run the circle class. It's different from this is circle one. Everything is just static here. So static is pure program class. Right here, this circle is data class. It's only used to store data. And then run circle is static program. So it's a programs class. It is a program class to run the circle. Is that okay?
I have a question about the circle one. Circle.
This one, yeah.
I don't get like why it says like circle double R and radius equals R on that third line.
This one is you want to create a circle, so you actually will fit in this R to this one.
Oh, so it's like getting the input.
Yeah, getting the input. So it's actually right here. You read in from keyboard, so you actually create an object based on this radius.
Oh,
and then your C1 will have that radius. Let's assume that right now you have C1. Let's actually copy this whole thing. Let's copy this whole thing and do it again. So right here, this radius we actually delete it. We don't declare available on the same name again. So right here, let's call it C2. C2. Okay, so this program so far, what happened is you ask for a radius, create a circle one. You ask for second radius, you create a circle two, so you have a circle class. Then you create a circle one. You also create a circle two. But this is circle one's radius is different from circle two's radius. You have one circle is big, the other one may be smaller. So this radius, you read another radius, you fit into there to create a second circle. These two circles are not the same one. Okay. So let's see. So right here, let's compile and run. So you will have circle 3.4. That's a big circle. So you calculate the area. Now I have a small one, which is 1.2. So these two, they have different radius. They also have different get area. So C1 get area, you calculate area for C1. This C2 the get area, you calculate area for C2. They call us their own instance function. We call it method. They both call this a get area, but the get area of the C1 use the C1's radius. The get areas of the C2 use the C2's get area, radius. Is that okay so far?
Yeah.
So static function is pure program. Non-static function is pure data. And this one is a function to call the data. Okay? To do testing. So that's what object-oriented program is. Object-oriented program means that you deal with objects. And circle is a class. A class is a data type.
Wait, so is a data type an
So data type is something you can declare right here.
wait, then what is an object? Is there
An object is you have a circle. Circle is a class. But circle, you may have many circles that you create. C1 is an object.
oh okay.
C2 is another object. These are representing two different circles.
Oh, okay.
You are supposed to know this. That means you will solo learn, you just rush it over. You did not actually pay enough attention to the solo learn. You rush to run to go to the coding too much. Okay, that's your problem. I told you you have 3 weeks to work on it. But you actually you need to speed up, but not quite quick. Okay, you go too fast that you did not really understand what's going on. They will defeat the purpose of having you to practice the solo learn. Is that okay?
Yeah.
I told you to finish for 3 weeks. There is a certain meaning. That means that you are not smart enough. You cannot finish it in 1 week. But you rush yourself. So the result is when you go to the coding bed, there are still a lot of things you did not pick up. In one say?
Yeah.
So slow down a little bit, making sure you actually understand everything. But you do need to put enough time to speed up the whole learning process. But during the whole way, you still need to pay enough attention to each topic. Okay?
Okay.
That's what I can suggest you. Not going to I don't want to compare you with other students because you start later. Okay, so it's okay. Don't worry. You have your time to work on it, but you still need to actually line up your schedule day by day. This week I need to finish this, and as a way you speed up yourself in that way. Okay, but you cannot say, "Oh, let me jump, let me do quicker." Okay, you ask for trouble. Okay, you know what I'm saying?
Mhm.
It's okay. A lot of students would have that kind of tendency, and most of them fail eventually because they are not following the instructions. Okay, anyway, so you do circle C1 equals new circle, that will create one object. You do circle C2 equals new circle, that create a second object. So these two objects, they represent different circle. And they have different radius. And they calculate the area. They do get area. The area is different. So this type of data, we call it non-static. So when you declare it's a public double get area, there's no static right there. No, there's no such thing as static right there. Okay. And then when you have a static means that it doesn't belong to any of the object. When you don't have a static, it means that the get area belongs to a certain object. Only the object can run that get area, and then it will calculate based on its own radius. So these two, the get area, will end up different value because they have different radius. While a static doesn't belong to an object, it will calculate no matter which object it is. Is that okay?
Yeah.
Okay. Then we go into the operators. This one is matching your using stuff. So this one plus minus times division modular. What I would like to say is this division more important, modular more important. Division is more tricky. So this plus minus whatever is not hard, but this division has two types. One is called integer division. One is called real division. So integer division, that's if we have 3 divided by 5, this will be integer division. So what will be the result of 3 divided by 5?
0.
You get 0. If you have a 3.0 divided by 5, what will happen?
0.6.
This one, okay, you know it. So basically, if you have the 3 divided by 5, you get 0, 0, 3. This one is called 3 integer divided by 5. This one is 3 modular by 5. So they use a percentage sign. It's very similar to divide, but it's only taking the remainder part. Okay. If you have 3.0 divided by 5.0, you will end up with 0, 0, and then 30, and then 26, 30, and you get 0. So this one is called real division. Okay? Okay, this part I think we know that's good. Okay, so one thing is like you have integer divided by integer, you will get integer. You have double value divided by integer, you get double value. You have integer divided by double, you get double. You have double divided by double, you get double. So any of the operand is double, you get double.
Yeah.
Both are integer, you get integer. Okay, that's the rule. Next one is increment and decrement. So you have A plus plus. Okay, let's assume that you originally have integer A equals 3. Then you have integer G equals A plus plus. So this A plus plus is you assign the value of the A to G, then A increased. So what happened is this one is the same as integer A equals 3, then integer G equals A, then A equals A plus 1. This whole thing is the same as this. Okay, this one we call it increment. So I plus plus means I increased. So I plus plus is the same as I equals I plus 1, or I plus equals 1. Okay, these 3 are all the same. And then you may have plus I. Plus I is different. Plus I, let's assume that integer A equals 3. Then you have integer G equals plus A. Then you will increase A first. So A become 4. Then 4 assigned to G. So this one is called plus A. This is A plus plus. So what I really read is that this one is getting the A after increment. This one is getting the A before the increment. So when you assign a value first before you increase the number. Okay? So same for the minus sign. Okay. This part is okay. This one is expression. You need to know how to convert it. Okay, so we don't waste time on it. First, only thing that you need to know is that multiply take priority over plus minus. Okay,
Mm-hmm.
so times division or modular, these are the same class. Plus minus, this is same class.
Mm-hmm.
You need to remember that. It's called operator precedence. Okay, right here, there's a table. You need to remember that. Next one is augmented assignment. Augmented assignment is you do have I plus equals 8. So this one, when you read it, we always read it as I increased by. Remember to read it as increased by. So I increased by 8 means that I equals I plus 8.
Mm-hmm.
So this one, I decreased by 8. Okay, so this English, you have to learn it by this. You remember the concept. So this multiply by, divided by, take modular by. Okay?
Mm-hmm.
Okay, then it's okay. This is called augmented assignment. Okay, augmented assignment. This one is data type conversion. Data type conversion, there are two types. One is implicit, one is explicit. Implicit means that you actually double d equals I plus 1. Let's assume that I is integer, I equals 3. So d will be equals 4.0. Is that okay?
Wait. Oh yeah. I got it.
So this we call it implicit. Implicit means that we don't need to convert the data type, but it will convert it. Okay. But if you do the other way around, you have double d equals 3.0, and then you say integer I equals d. That is wrong. You cannot do that. You have to do integer I equals int d to convert it from double to integer.
Wait, the integer has to be in parentheses.
Hmm?
The integer for the for D has to be in parentheses.
Yeah.
Okay.
So this is called casting. This is what we call it casting. So basically, byte is 8-bit, integer is 32-bit, long is 64-bit. These are integers, and then float and double. So basically, whatever the right side is longer. So longer one converted to shorter one is not okay.
Mm-hmm.
Shorter one converted to longer one, that's okay. So when you do backward, you do need to use casting. You do forward, you do not need to have casting. That's called implicit casting.
Okay.
Okay. So this table, you need to remember that. And then one more data type is after the double, there's an even longer one that's called string. Okay. Not shown in this table, but you will do that. So you convert a 3.9 to I using casting, you will truncate the 9, so it becomes 3. This one 3.0 comparing converted to I is also 3. So these two end up with the same value. It
Okay.
just truncate everything you have. Okay, they just convert everything that you have. Now this one actually is a problem you want to get rid of the 2-digit. Okay, you want to run it to this digit. So what you can do right here is that you have 23.4567 times 100, your decimal point will move to here. Then you do quantization. Then you actually lose the rational part. So you become 2, 3, 4, 5. Then you divide it by 100.0. Then you move the decimal point to here. So it becomes 24, 3.45. Is that okay? This
Yeah.
whole process will truncate 2 digits away. One thing is that never compare two double value, because double value you actually will have wrong off problem. 1 minus 0.1, 0.1, 0.1, 0.1, 0.1. It may not be 0.5. It may have small quantization error because of the storage of the floating point numbers. This we call it wrong off error. So never compare 0.5 with this.
Oh,
Okay,
okay.
that you will end up wrong. Okay, we shall roughly go through it because we have limited time, so we need to do. So next one is mm, let's see. Okay, let's assume that we have a integer seconds. Okay, so how many seconds? This many second is how many hours and how many minutes and how many seconds. If we want to convert it to our millisecond system, I give you so many seconds.
Mhm.
How can I know how many hours it is, how many minutes it is, and how many seconds it is?
Um, you divide it by 3,600, and that's
Mhm.
how many hours there are. Then you could mod it by 3,600 to get the amount left over. Then you could divide that by 60. Then you just keep on doing that until you get seconds.
Mm. Okay, so this is what the answer
But
is. Hmm?
shouldn't it be mod equals?
Oh, this is yeah, sorry, sorry.
Hmm.
Okay, okay. So we actually finished this chapter 2. Let's go to the chapter 3. Okay,
Yeah.
the chapter 3 is application interfaces. I'm sorry, this is chapter 4. In my chapter is chapter 4. This one is simple. We'll go through it quickly. So this one, it talk about what is class, what is math class, what is a library, what is a Boolean value. So Boolean value give you true or false. I think you know it already. So this one, okay. Greater less than, this one, okay. Logic value, what you need to know is not and or. This inclusive or is not tested. So sometimes we use the not equals for the inclusive, okay?
Inclusive or? Oh, okay.
We use a not equals to do inclusive or.
Oh, okay.
Characters are single letters. I think we talked about it last time, right? This one.
Yeah.
For UTF-16, so we talked about it. ASCII table, we need to remember the ASCII table, especially the A to G part, lowercase a to D, and the number parts. These three sections we need to remember. And then there's a classical character class. You need to remember there's a digit to lowercase to uppercase. These different functions will be tested. Okay.
Oh, I see.
Math class, you need to know about the number class, integer class, double class that you need to know. And there's also another one called math class. So they are number class. Number class representing numbers. Math class is for the collection of the math functions. So they are math.pi. Usually you need to remember this. And integer the mean value and integer the max value. These are the largest integer for the machine that you have. Okay.
Mm-hmm.
So this three usually is something you need to remember. Function, you need to remember these different service function in the math class, especially the math.abs and math.random. Math.random, we will later introduce it, but right here, you need to at least know this one,
Mm-hmm.
this one, this one. Okay. So when you have a final, means that it's a constant that you cannot change. Okay. The sine cosine is okay. AP doesn't test it. The random class is to generate random number. Okay. Master random is a random number generator function. It will generate a random number between 0 and 1, but not including 1. Okay.
Mhm.
Okay, this one is master random. Next one is API. API means the library that you have. So they are a big API. So scanner is in the API.
Mhm.
Okay, so it's someone who has already written the program for you. We call it API, application programming interfaces. So here we do have Java SA standard editions API. These are different functions that are available in Java. So math.random is a API from the math class. There are a lot of different classes that provide you the functions. So typically what you need to learn in the AP level are these and these. Okay, these different classes that you need to learn. Okay. We'll talk about them later. System class, we talk about it. It's the system.in and system.out. Okay. These are two objects that you have. Scanner is from scanner class. Is responsible for tokenization of the data. Okay, when you read in data.
Yeah.
Okay, we roughly go through it. Any questions so far?
No.
Okay,
No.
so today I cannot go too fast. Okay, so I'm probably will start right here. Any question?
No.
So if you have question, you need to ask. Okay, not
Okay.
only the one that we teach you, or also including your UC scope problems. Okay,
Okay.
and you have to move a little bit faster in UC scope. Okay,
Yeah.
because the ultimate goal is that we want you to finish the AP course much earlier than the school end this year, the next year. Okay, because you need to save some time for reviewing the AP course. So if you can finish this course as early as possible, the first semester as possible, then you sign up the second semester and get started right away. Okay,
Okay.
is that okay?
Yeah.
That would be helping yourself, not helping myself, helping yourself to get more prepared for future competition. Okay.
Okay.
If you just sleep, you just let the time pass away, and then you just do like whatever normal high school do. Then what happens is that you lose the whole sophomore year, and then when you compete, you are already in the junior year. You are out. You probably not easy to get any division. Okay, you know what I'm saying?
Mm-hmm.
Okay, so you have to help yourself to speed up. Okay, that's what I
Okay.
can tell you. That's why I think your parents want you to get started early with me. Okay.
Okay.
Okay. Anyway, good luck. Okay. So far you're doing okay, but still need to speed up. Okay. Good night. Bye bye.
Okay. Bye.